flight of the 787-9. This variant offers increased capacity and capability and retains more than 80% commonality with the Dash 8. This 9-part video shows the differences between the 787-8 and Dash 9 from a maintenance perspective. 1. Dimensions and performance. The body of the 787-9 is 10 feet longer in front of and behind the wings for a total of 20 feet or 6.1 meters. This increase requires that many systems are revised. For example, longer wire runs, fewer interconnect boxes, more speakers, speaker drive modules, and passenger service modules. Lengthening the cabin allows for a 16% increase in seating, or roughly 38 more seats in a generic 3-class layout. Cargo volume is increased to 1 pallet in the forward bay, plus 4 LD3 containers in the aft bay. With increased capacity, it is important to strengthen the structure and the main landing gear. This is partly accomplished with improvements in the composite technology, for example, advanced floor beams and composite door surrounds. Increased weight also requires improvements in engine performance. Reference your aircraft maintenance manual and flight crew operations manual for specific information on your airplane capacity and performance capabilities. 2. Electrical power. The 787-9 has larger ram fans than the Dash 8 to increase cooling airflow on the ground. The ram fan motor controllers are also larger to accommodate the larger ram fans. The Dash 9's auto transformer rectifier units and common motor start controllers have higher kilowatt output settings to run the larger electric motors. Component layout inside the P700 panel is different. The P700 incorporates a new contactor called the L1 Ram Fan Contactor, or RFC. This contactor allows simultaneous operation of both ram fans on the ground while powered by the same Common Motor Start Controller, or CMSC. The electrical maintenance page 2 for the 787-9 shows the additional CMSC power supply for the left ram fan. The equipment racks in the crown area of the 787-9 are different. The racks mount the line replaceable units, or LRUs, vertically along the top of the cabin for easy access to the components. 3. High-frequency communication system. Location of the antenna and related couplers is the main difference between the high-frequency communication system of the 787-8 and the Dash 9. The Dash 9's antenna is a cable antenna, and it is mounted underneath the skin of the airplane. Access to the HF components is under the 321LL and 321LR access panels located at the base of the vertical stabilizer. 4. Flight controls, flap positions, and yaw control. There are 3 additional flap positions for the Dash 9. The new flap settings are 10, 17, and 18 and are used during takeoff to help provide more lift for the bigger airplane. The 787-9 has 4 modal suppression accelerometers, or MSAs, 2 forward and 2 aft. The Dash 8 only has 2 aft MSAs. The additional MSAs for the Dash 9 provide lateral and vertical acceleration data for better control of the larger airplane. 5. Flight controls, empennage door actuation system. The empennage door actuation system, or EDAS, is a new system only available in the 787-9. It improves the flight control system by reducing drag during different phases of flight. The vertical and horizontal stabilizer, as well as the leading edges, are constructed of perforated panels. Laminar airflow is created by a boundary layer suction through the perforated panels. A suction is provided by venting the leading edge cavity to downstream areas of low pressure. The purge and suction system, or PASS, includes doors, door mechanisms, and a fully automatic empennage door actuation system, or EDAS. EDAS automatically controls doors located on the vertical and horizontal stabilizers. There are 3 EDAS door positions depending upon speed and altitude. One position closes the EDAS doors when the airplane is on the ground, a second position for low airspeeds, and a third position for high airspeeds and altitude. The Right Flight Control Electronics, or FCE, controls a 4-channel motor controller, communicating via AirInc 429. The motor controller communicates with the right FCE and also receives 28 volts DC from the Remote Power Distribution Unit, or RPDU. The controller sends electrical power to 4 electromechanical actuators near the leading edge of the vertical and horizontal stabilizers. There are 2 doors on the vertical stabilizer and 2 doors on the horizontal stabilizers. When the airplane is on the ground, all EDAS doors will be closed. At low airspeeds, the motor controller receives an input from the right FCE and the doors open forward for the purge mode. The purge mode opens the door and scoops airflow at low speeds to provide pressure purging of the leading edge perforations. At higher airspeeds, the motor controller receives an input from the right FCE and the doors open in the aft direction for the suction mode. Air pushes into the perforated holes in the leading edges and exits out through the plenum or scoop. During deceleration, the doors go back to the closed position. An operational check is performed through the Central Maintenance Computing Function, or CMCF. EDAS values are shown on page 4 of the Flight Controls Maintenance page. 6. Main landing gear. The 787-9 main landing gear is strengthened with larger wheels, brakes, tires, door actuators, and door unlock mechanisms. Machined titanium drag and side braces are also used to compensate for the increased operation weights. Even though the Dash 9 landing gear is larger than the Dash 8, it retracts more quickly after takeoff. This is a new process that automatically opens the main landing gear body doors as soon as the airplane is airborne. 7. Fuel and nitrogen generation system. Wing structures are different in the areas that vent fuel. Instead of vent tubes used on the Dash 8, the Dash 9 uses 4 hatch section stringers. Hatch section stringers are integrated in the structure of the upper wing skin. A combination of aluminum vent tubes and hatch section stringers are used in the center tank. The cross-flow check valves on the Dash 9 have been relocated to the surge tank. The center tank jet pump ejector has been redesigned for ease of removal and installation. Therefore, it is not interchangeable with the Dash 8. 8. Power plant. Other than a higher thrust rating on the GE NX-1B engine for the 787-9, there are no major power plant differences between the GE engines of the Dash 8 and the Dash 9. 9. Air conditioning. Since the 787-9 is bigger, it needs more cooling, more heating, and more air. The Integrated Cooling System, or ICS, is different on the Dash 9. ICS liquid is distributed in parallel for more even distribution. An upper recirculation air heat exchanger, a temperature control, and a shutoff valve are added to provide more efficient cooling. The upper recirculation air heat exchanger is located forward of the upper recirculation fan. The upper recirculation fan and controller are larger on the Dash 9. This fan takes warm air from the crown and forces it through the upper recirculation air heat exchanger and back into the overhead cabin distribution system. For ram air cooling, the primary and secondary heat exchangers are larger on the Dash 9. The ram air fan is more powerful in order to pull more air for better cooling across the heat exchangers. The ram fan motor controller is also larger, so it can supply adequate power for the bigger fan. The miscellaneous equipment cooling system has been removed because the in-flight entertainment system is now located on the E2 rack in the forward equipment bay. The alternate ventilation system, or AVS, is different on the Dash 9. The Dash 9 uses the aft outflow valve instead of an AVS valve to draw air in case of air conditioning failure. The aft valve opens in reverse to draw air in. This air vents out of the forward outflow valve. This saves weight and does a better job of alternate ventilation. There is a new indication for alternate ventilation. Ventilation ALTN can show at the bottom of the air conditioning synoptic page. The Dash 9 has left and right ground connections for conditioned ground air. The right ground connection was added in order to provide more conditioned air for the larger airplane. Lastly, the Dash 9 incorporates more inline heaters at door 3 galley and at the aft galley as shown in the synoptic. This concludes the 787-8 to Dash 9 differences overview.